In this challenge, I want you to pick some text of your choice from a document you have, or an online article, or some wiki page. You'll create a program to read the text document with one of the methods we talked about in the last couple of lectures. You can pick any method you want to use, but whichever you use, your program should do the following. Tokenize the text into words, remove any punctuation. Ignore words with 5 characters or less. Count the occurrences of each word. Display the top 10 most used words. The point of this exercise is to see if you can pick out what the article might be about by simply getting the most used words. After you use one method, try a second method. If you used a method that used a stream, try some code without using a streaming method or vice versa. Okay, so go away and give that a try. When you're done and want to see my solutions, come back and we'll walk through this together. Welcome back. How'd you do on that challenge? Were you able to figure it out? Did you try the bonus part? Let's get started. First, I've created a project called Reading Files Challenge with the usual main class and method. Before I write any code, I'll create a new file at the root of this project called article.txt. For my article, I've copied the text from Wikipedia for the Grand Canyon. I'll paste it in my file warts and all, as the saying goes, meaning I'll just leave it exactly as I got it. Now, I use a buffered reader because who knows, maybe I'll use this code against really large text files later on. In the try with resources, parentheses, I'll create a buffered reader variable, just be able to keep it short and assign that a new instance of this class. I'll pass an instance of file reader using the string literal article.txt. I'll add a catch block because I know I need it. If there's an error, I'll just print it and ignore it after that. I'll be using the method lines that returns a stream of strings. I'll wrap that in a system.out_printf statement because I first want to print just the count of lines in the file. My argument will have the call to the lines method chained to the terminal operation count. Running that, I'll get that my file has 533 lines in it. You'll likely get different numbers for this if you are on a Mac or running on Linux. One thing I do want to point out to you while we're looking at this is what happens if I try to execute this method again. I'll just copy and paste that line of code here. If I run the code like this, I get 0 lines for the second statement. After the terminal operation on the first pipeline, the file pointer is at the end of the file. I'll be talking about ways to maneuver this file pointer in a later section through the means of mark and reset methods. For now, it's important to understand you can't use back-to-back calls like this. I'll revert that last paste and I'll comment out that first statement. Next, I want to count the number of words. There's a few ways to do this, but let me show you one that uses this lines method again with a regular expression pattern. First, I'll set up a pattern variable and compile a pattern with the string I know the scatter class uses to split strings into words. I'll again set up a printf statement, this time for the number of words. I'll start with my source, lines from the buffered reader. I'll call flatmap and use a method on my pattern called splitasstream. This method will split the string and return a stream of string. I need flatmap here to flatten the hierarchy before I can use the terminal operation count. If I run this code, I'll see that I have 13,799 words in this file. Another option would have been to split the string. I'll comment out this flatmap and show you another version. I have to create a stream here because flatmap only works on a resulting stream, so I'll call stream on arrays, passing it the string array I get back by using my pattern on each line. Running this, instead of a flatmap, I could use map and sum. I'll copy this entire system.out.printf statement and paste a copy just below. I'll comment the previous statement out since I can't call br.lines consecutively like this. I think it's a good idea to keep exercising some of these stream skills, so I'll just show you this next variation in case you find flatmap a little confusing. I'll remove that commented out flatmap here and the 2 operations below it. This time, I'll use map to long as my intermediate operation. My lambda expression will still split the string using the pattern, but this time it will return the length of that resulting array. And instead of count, I want the terminal operation to be sum. Running that, I get the same result, proving once again there's no right way. This way is probably more efficient because there's no overhead with the streams and it's processing a smaller number of long values versus strings. Okay, I'm going to comment that out again. Let me get back to the task at hand. I'll set up a local variable for my result and start out with the source, br.lines. I don't want to do a flat map here because I want to evaluate every word. One of the requirements was to get rid of trailing commas and periods, so I'll call map calling replace all on the word using a regular expression that stands for any punctuation. After this, I only want to evaluate words with more than 4 characters. I'll make all the words lowercase, so I don't have duplicates just based on case. The terminal operation will group by the whole word and count all instances of the same words. Now, I need to print out the results, and I've said I only want the top 10 words that have the highest frequency. I'll stream again by getting the entry set of my result and calling stream on that. I'll sort by the entry value, which is the count of occurrence, but I want this to be reversed, so I can pass a second comparator. Here it's reverse order on comparator. I'll limit the results to 10. And I'll print this information, first the key, the word, and then the number of occurrences. Okay, I'll run this and see what might be some of the most important words about the Grand Canyon. Not surprisingly, Canyon and Grand are at the top, but I've got National and River and Colorado. Some of these words look like they're more geared to Wikipedia, like retrieved and original and service maybe. I can create a list of words I want to exclude. I'll do that next. I'll just set up a list of excluded words here. So Grand, Canyon, retrieved and archived. And maybe service and original too. I'll need to filter out the excluded words, and I can do that by checking if the list contains the word, and if it does, I'll return false so the word won't be included. Okay, now if I run this, I get some other descriptive words, so national, likely because it's a national park in the US. River in Colorado, because the canyon was carved out by the Colorado River. Water is a really big deal for this canyon and river, so it's not surprising that's there, and Arizona is the state it's located in. So that's a nice snapshot of the article in 10 words or less. I'll try another example. This time I'll use Big Ben. I'll copy this text from the file in the resources folder called bigben.txt. I again want this at the root of the folder. I'll change my code so that I'm pointing at the bigben.txt file. I'll run that. If you didn't know anything about Big Ben, you might guess that it has something to do with a clock tower in London and that it has bells. I don't know what the different months are all about, so maybe I could add those to the excluded words, but anyway you can kind of get the gist of this topic in a few words. Okay, so the bonus part of this was to do this with a stream, and then without, or vice versa, so I'll do this without a stream next. I'll use read string on files. First I'll add a separator line. I'll then create a string variable, input, assigning it what I get back from files.readString, and I'll pass that a path for the Big Ben file. I can replace all punctuation in the entire string with one call, so that's kind of nice. I've got a compiler error on readString, and it's the IO exception, so I'll add a try catch. I'll just move that last input statement into the try block. Next, I'll set up my pattern. This is going to be different because I'm not splitting or tokenizing. I use matcher to find all the words in this big string. My pattern will look for one or more word characters. I'll get a matcher, passing the matcher method all the text from my file. I'll set up a new map manually, keyed by string containing a long value. Next, I'm going to use matcher's find method to loop through each match or each word it found. I can use matcher.group to get the next word and make that lowercase. I'll check the length, making sure it's greater than 4 characters. I'll use merge, putting 1 as the first value and incrementing by that if it's not a new keyed entry. That'll populate my map with distinct values and counts, so next I'll sort this and print it. I'll first create an array list of the entries. I'll sort the entries by the value in reverse. I'll loop from 0 to 9, or less if the text doesn't have 10 entries. I'll get the entry from the list. I'll print it as I did before. Okay, that's it, and I can now give that a shot. In this code, I didn't exclude any words, but you can see the counts for clock and tower are the same, and so on, so this code is also working. I could also have included that check for 5 characters in my regular expression. I can do that with curly braces, then 5 comma, which says I want at least 5 word characters, but I'll take more. I can comment out that if statement now around the merge. Running that, I'll get the same results. I could have also just used the method on Matcher that returns a stream of matches, but the challenge was to use a streamless option. Okay, so I hope you got a lot out of that exercise. Maybe you came up with several different ways to do this. Think about posting your solutions in the Q&A. It would be kind of fun to see how many different variations you guys all came up with, because there's probably a ton. Again, there's not a really wrong solution. Some might perform better than others, but with small files, you don't have to get too concerned about the details of performance. In the next video, I'll start talking about writing files, so I'll see you in that video.